Industry 4.0, robotics, analytics, artificial intelligence. All these words made it to the textile industry everyday vocabulary. Industry 4.0 is focused on improving efficiency, profitability, security and trust, leading us towards a circular, more responsible and sustainable economy, which is capable of responding to an increasingly demanding and more awake society for consumption. This permanent transformation in consumer demand is the driving force behind innovation. The constant need for new products, adapted to new times, motivates the textile industry to the research and development of innovative solutions. AN1 – Fabrics prototyping by machine learning. Textile and clothing production is a complex process in constant improvement. Making adjustments to this scale is sometimes time-consuming. In this activity, we investigated and developed a tool for the dematerialization of samples and sample factories, implemented in a digital platform for the integration, treatment, and analysis of decision support data in virtual fabric prototyping. Several machines work with variables, combining them in order to make the prototyping processes of a fabric faster and more successful. And for what purpose? This innovative solution makes it more sustainable to test and find a higher quality product with less time investment and resources. This process combines all possibilities based on the available yarns and materials, combinations tested by complex algorithms which learn and test variables with incredible speed, as shown on the digital platform, answering the initial question: what is the most viable option in the production of a given fabric with specific characteristics? The production process has multiple variables and a constant exchange of information. In today's context of an open market, the agility and speed with which it returns and presents solutions are vital for success and business growth. The development of fashionable garment fabrics is subject to great seasonal pressures and responsiveness, and with this innovation, it becomes more effective in responding to the challenges faced by the textile industry. AN2 – Prototyping of sports clothing by motion capture and Internet of Things. What if our clothing could show more about us than just style or personality? We started from this premise to address the application of concepts commonly associated with the automotive industry or smart homes, motion capture and the Internet of Things, which can now be applied to prototyping sports equipment. High-performance athletes object of special attention due to their ability to overcome barriers, extreme focus, and their resilient spirit. Nowadays, we also know that the equipment designed for these athletes also have a great influence on their performance, and for this reason, the design and development of technical sports clothing is a very complex and challenging process that encompasses several phases. It implies permanent contact with each athlete, as it involves constant re-engineering with the production of a large number of physical prototypes. Only in this way is it possible that the equipment to be developed corresponds to the real needs of each athlete and sports. In addition, each piece of equipment must comply with the specific regulations of the entities that oversee each sport. A product development tool was conceived, and it allows the digitalization and dematerialization of physical prototypes in the production of technical sports clothing. It reduces the time necessary for the presentation of prototypes and assembly of equipment that takes into account the physiological and biomechanical characteristics of the athlete. The information generated by this tool allows the company to select materials with the most appropriate properties for each area of the body, also known as comfort mapping. Different levels of compression, breathability, and elasticity, among other parameters, can be applied depending on the athlete's needs and the sport's requirements. The product development tool incorporates motion capture technology and other sensors that collect information such as physiological, biomechanical data, and other information related to the athlete's movements, which are important for defining the prototype and to select the raw materials to use so that the equipment corresponds to the real needs and expectations.